All right, number 5 asks us to find the sine of the inverse tangent of the square root of 6. So in other words, there's some angle, let's call it theta, that's equal to the inverse tangent of the square root of 6. And we want to find the sine of that angle. And the trick with this is that we don't actually have to find theta. We can find this whole thing by just drawing a little picture. And here's how we're going to do that. If theta is equal to the inverse tangent of the square root of 6, that's another way of saying that the tangent of this angle is equal to the square root of 6. And you can see that if you took the tangent of both sides, the tangent of the inverse tangent would cancel out. And over here on the other side, you'd have the tangent of theta. So the tangent of theta, this angle that we're looking for, is equal to the square root of 6. So let's draw a little picture here. We'll just draw a picture of a right triangle. And it doesn't matter what your triangle looks like as long as it's a right triangle. And we're going to call this angle right here theta. And so if this angle is theta and the tangent of theta is equal to the square root of 6, remember tangent is equal to the opposite side divided by the adjacent side. So let's make this opposite side square root of 6, and we'll make this adjacent side 1. So now we have a picture of what this tangent of theta equals square root of 6 looks like. And now in order to find the sine of this theta, we need to find the hypotenuse. So the hypotenuse, let's call that C for right now. And we'll use the Pythagorean theorem to find C. We know that C squared is going to be equal to the sum of the squares of the other two sides. So 1 squared plus the square root of 6 squared. So 1 squared is 1, square root of 6 squared is 6, so this is going to be 7. So C squared is equal to 7, so C is equal to the square root of 7. And we can now replace this C with square root of 7. So now we have a complete picture of what this triangle looks like with this angle theta. We still haven't found theta, but we don't need to, because what we're really looking for is the sine of theta. And we have enough information now to figure out what the sine of theta is. So the sine of theta, and remember theta was the inverse tangent of square root of 6. So if we find sine of theta, we've answered our entire question. The sine of theta is equal to the opposite side over the hypotenuse. So that's the square root of 6 over the square root of 7. We don't want to leave this answer like that. Let's rationalize our denominator by multiplying by the square root of 7 over the square root of 7. And so on the top, we're going to get the square root of 42. And on the bottom, the square root of 7 times the square root of 7 is just 7. And so that's going to be our answer, the square root of 42 divided by 7.